In our previous session, we had seen the overview and types of RC plane. Now, let us move on with the RC plane configuration. There are two types of configuration that you have to be aware of: electronic configuration and construction configuration. The electronic configuration: Motor is the power plant of your plane. The motor will turn your propeller at a high speed to propel it through the air. The standard motor that you put in your RC plane is brushless, which means it runs on AC current. This is why you need an electronic speed controller to convert the battery's DC power into AC. ESC, Electronic Speed Controller, does several things. It is an electronic circuit that controls and regulates the speed of an electric motor. First, it converts your battery voltage down, which is what your receiver runs on. The second thing the ESC does is it converts the DC power from your battery to an AC current, which is required by the motor. Brushless motor runs on AC current. LiPo batteries. Batteries have several different characteristics. LiPo, lithium polymer batteries, are standard for the RC hobby. The first thing to talk about is its battery's voltage. While the battery's exact voltage may not be printed on the battery itself, but it will tell how many cells the battery has. LiPo batteries are made up of cells. Each cell is 3.7 volts. The next thing is the ampere capacity. If the battery shows is a mAh battery, this means the battery can supply 2200 milliamps over 1 hour period. Finally, there is a discharge rate. This particular battery has 25C discharge rate. This is how much current the battery is able to supply. The higher the discharge rate, the more power you will get from the battery. Propeller. An aircraft's propellers are airfoils similar to a wing installed vertically to create thrust to drive the plane forward. Attached to the engine, they spin quickly, creating lift from the pressure differences they create only instead of this lift causing the plane to move forward. It drives the plane forward, creating thrust. This thrust and forward motion in turn causes air to pass over the wings, creating the vertical lift. Servos are what move your control surfaces. The servo plugs into the receiver. The aileron plugs into channel 1 on the receiver and the elevator plugs into channel 2 on the receiver. BEC, Universal Battery Elimination Circuit. When buying an ESC, buy the one which says BEC or UBEC. Basically, BEC is an electronic circuit designed to deliver electrical power to other circuitry without the need for multiple batteries. Transmitter and receiver. A transmitter and receiver of a radio-controlled aircraft must both be on the same frequency so the aircraft can be controlled in flight. Traditionally, this transmitting and receiving frequencies were referred to as channel, technically a frequency channel. This is not the same as the number of survey channels that a plane can have, but can be confusing as both are usually referred to as channels. Moving on to the construction. Fuselage. The plane's body or fuselage holds the aircraft together, with pilots sitting at the front of the fuselage, passengers and cargo in the back. Wing. An aircraft's wing are critical to flight through the production of lift, but they have many parts of the wing to control this lift and direction. Ailerons are one of the three primary control surfaces that control a plane, along with the elevator and rudder, and are located on the trailing edge of the wing to control the roll of the plane. Landing gear. Landing gear is located under the belly of the plane, consisting of a wheel. Tricycle type wheels are common for general aviation, with one wheel at the front. Horizontal stabilizers keep the aeroplane's nose from moving up and down. Pitch. The hinged part of the horizontal stabilizer is the elevator and is one of the primary flight controls. Rudder. The vertical stabilizer allows the aeroplane to weather vane into the relative wind. This helps prevent the side-to-side motion of the aircraft's nose. Understanding the basic functions of how these parts interact is the first step to understanding the principles of aerodynamics. I hope I have made myself clear enough to make you understand the components and functions. Let us proceed with RC design in the next session. Thank you.